Thank you, Dr. Saloni, for inviting us to come, and especially I'm very thankful for you inviting the students in our department. We have 4 here in my group that I think have benefited a lot from the talks and the questioning part in the series of talks during the last 1.5 days. It's very nice, and personally I have also learned a lot. What I do in the department is maybe not directly related to bioenergy. So what we do in our group is more related to materials. And we do a little bit of work, research work in the area of enzymes, enzyme activities. But we're looking into very very specific processes as opposed to the big picture, including the economics, policy, and other items that are very, very important, at least for industry. So I guess I was picked up by Dr. Saloni because I'm an outsider in this field, and maybe can bring some maybe outside ideas that sometimes can help in the conversation. So that's what I tried to prepare. And I prepared my talk during my time here. When I was sitting, I was thinking about how a round table will look like. Is it going to be round? Is it going to be a square? I was not too sure. Or random. So I decided to make a mixture between what you mentioned last time, recently, about having some conclusion remarks, or perhaps some sort of discussion. But for that, I will need your help, because what I'm going to do, what I intend to do, is to present some facts and maybe ask you to help me understand the answers to those facts and questions, because I have no answer to any of these questions. So the way I organize this sort of conversation that I don't think we can call a round table is first look into the components in today's and yesterday's presentations. They had to do with biomass, obviously. There were 2 talks about biomass. Collateral issues such as strategies, logistics, and issues related to exports and supply chain analysis that are very important. And then we have been looking into life cycle analysis, that was today, and also on yesterday, and a little bit about the 2 components of the outcome of all these processes, and that will be the solid fuels and liquid fuels. So I can see there was a lot of thoughts how this program was put together, because all this makes this integrated circuit that you see on the right, where you have different considerations, environmental, chemical, technological, industrial, etc. So it's very nice. So what I have here first is a slide that I was able to pull out from internet a few hours ago about the overall utilization of biomass, and what we have discussed today and yesterday, I guess, having mainly biomass in the way of cellulose biomass, trees, woody biomass, for the most part. But there are other considerations such as waste biomass, for example, waste paper or recycled paper, and algae. And I have no clear idea what is the status of these 2 components when we factor them as also part of the biomass. So my first question to the group is, what is the status of that? Have you read, do you know of what the status is for these types of biomass compared to woody and non-wood agricultural biomass? Any thoughts? And again, I may not have an answer or don't have an answer, but I was just wondering what the status is, because I know there are many efforts in these directions. In our department, there's a little bit of work related to the use of waste paper for producing bioethanol. There is no research in our department about algae, but I think it's also something that is sounding a lot. Any thoughts?
I think with the algae, the biggest issue that's come up is like the nutrient demands. I don't know much about it other than that. We've been in this industrial microbiology class. Right. That was basically like the biggest limiting step is that, the nutrient demand for the biomass that you're actually producing is second for the time being. course, you can. I guess they're trying to manipulate the species and stuff. And some production is being done with GMOs, and some is not. And I know for a fact, a friend of mine's uncle who owned a research, algae research, I don't know, company or something down here in Raleigh, actually, recently shut down that part of their research.
Right, right.
But they were working with unmodified, like just natural strains of
Right.
algae.
Yeah. And one
One item that can be added is scalability of those processes, right? So there are many issues there, but at least for us to think about, right? So we're not going to give any statement about the status because honestly I don't know, but I think to consider, right?
At NC State, there is a group working with that over agriculture. That there is a RFP from DOE just requesting research with algae and the improvement and so on, and there is some funding about it. There are a lot more challenges, and I guess we don't get much. Now, in terms of waste, waste is there is a huge trend and opportunity, yes, from the waste management facilities. Just go to the urban waste and trying to find treasures down there. One of the issues that we've been facing is sorting and separation.
Sorting, logistics, separation.
It is.
That's a major issue in waste.
It is very expensive to do. So
That's right.
we do it at the source. So when we produce the waste, if we do the separation, as we do with recycling paper and glass and aluminum and all those stuff, that might help. But other than that, that's
Yeah, so a couple of points to consider. Some additional points that maybe we didn't discuss too much, but I think are also important, is those related to job creation, obviously. This is very important. In the life cycle analysis, I didn't see anything about water. Maybe I'm mistaken, but that's also a very important component. And then social factors. That's also very critical, even though this is not factoring so far as I can see. The other component that I think is very interesting that we can think about is co-product generation and utilization. So in many of these processes, you were talking about lignin, for example, and it looks to me that there is a renewed interest in the utilization of lignin. So these are things that can change a little bit the landscape, the economic landscape and the feasibility landscape that we were discussing. So just to bring up some of the issues that I think are important for us to know. Then we look at Trevor's talk, and here I have something from the Energy Independence and Security Act in 2007. I think at that time, the target for 2022 was for producing cellulosic biofuels in a scale of around 16 billion of gallons. And maybe you mentioned a different number. I think you referred to 22. Okay. Okay, so, and maybe there are revisions to this. The point is that if we stand here in 2012, my guess is that we are far from those targets, right? And the question for us is why? Why are we far from those targets, or why not? So, there are many issues. One, investment, and to look into the economics of the processes that are related to that. But I think the reality that is shown here is maybe that there is a dephase between what was planned years back and what we have nowadays. And there are obviously a lot of technological challenges. And this is all driven by technological challenges.
Is that target realistic? I mean, is that 36 number billion gallons. Is that realistic? Is something that we can really achieve? I mean, because in 2008 that was might be the dream, but is that
It's not realistic because nowadays
we're not even close?
right. So yeah, that's a fact, right? So there is a message here, and that message is that the technology in these processes is maybe more complex than initially thought, and maybe the advancement in this area is going slower than we thought.
Or we need more investment?
Or we need more investment, right? So, and I have a slide about that at the end. So we're talking, yes.
Conventional biofuel. Can be
The corn, right? And I have a comment about that. Yeah. So conventional biofuels from corn have been met, but then what if there is more produced? How is that capacity is going to be absorbed? And there are a lot of unknowns. So I would like to comment on that. But all in all, what we see here is that there are many challenges, and
These challenges are summarized in this slide that I took from internet. And they come from the beginning, from the biomass, from pre-treatment. And in this case, they were talking about more like adjusting the biomass for the future processing, not to pre-treatment in a biochemical platform conversion. Then we have these two platforms that we have discussed, thermochemical by Dr. Park and biochemical by pretty much the rest, product recovery, and at the end, biofuels, bioproducts, and power, biopower. And those challenges are maybe summarized here, and today I heard in the morning very early about supply, biomass supply, and main challenges is reliability. Supply, consistent quality and chemical composition, and affordable delivery. In the pre-treatment, has to do mainly with solids handling, biomass. That's, I learned, very important in pelletization and other processes, and biomass feeding. And then in the conversion, the key challenges have to do with the product's yield, construction of materials in those processes, the catalyst, and fermentation organisms that are still falling short to obtain the yields that are required. And then finally, in product challenges, we have the separation, catalytic upgrading, and recycling loop and process integration. This was not discussed during this 1.5 day. So a little bit of some thoughts about these challenges that I want to discuss, starting with the biomass and going down to the products. And I have here some maybe text lines that can maybe be used for the discussion, and then underline I have what I want to focus on. So one thing here is that cellulosic feedstock supplies are known to be abundant and diverse, which is good. They are potentially inexpensive, but there is, I see, a lot of variation in those prices. And those prices from this morning talk by Dennis are going up, and that has to be factored in. And then there are other issues, maybe more on the negative side, that many of these costs of biofuel production are not reflecting or including environmental or related impacts. Maybe not, maybe this is my understanding, but I will have to ask Trevor and Jesse if this is the case in their economic analysis.
So for estimating cost of food production, when we do it, there's a disconnect with environmental.
Right.
Jesse, can talk about bridge that gap. Yeah, there's a trade-off there.
Right.
Some cases it works out, but the pathway is actually more profitable, but
It's not the case.
they're counted.
Right. Right.
Maximize
Right. But it's a point that we need to keep in mind. Yes, Ingrid.
Well, I guess, yesterday, the life cycle analysis.
Right.
Or-
Can be factored in there. Yes. Yes. That's great. So moving on, related to supplies, when I put a map, this is what we see. West Coast, we have a lot of non-wood biomass, poplars, switchgrass, sorghum, some of the feedstock that you consider, Trevor considered in his simulation. And then when we move to the East Coast, we're looking at different type of location where we have poplar and also pretty much other non-wood biomass, but also eucalyptus and pine in the southeast. And that's critical, that's important to know where the location of those biomass resources is. And my question to the group here is, then if we are to select these different types of materials or feedstock for thermochemical or biochemical processes, what would be the ideal one? And it's a question maybe that you can answer much easier than me, but what would be the ideal situation here? What is the situation between that match of source supply and location and the intended production units, either thermochemical or biochemical? Comments? Right. In each case, if you can comment on that.
Possible, which I guess would be impacted by biomass growth rate. It's like a biomass system. So it's not harvesting.
Right. Now, in thermochemical conversion, there is maybe more resilience comparing hardwoods against softwoods. In the case of biochemical conversion, then the preferred feedstock will be hardwoods, right?
Maybe the other very important consideration for thermochemical conversion is inorganic. For example, for the best pyrolysis, they use different types of catalysts. That pyrolysis, in the phase of catalyst, then they ship it to the refiner and they use different set of catalysts to do it. So even though it's very small amount of catalyst to start with, and depending on what type of catalyst and amount, that may kill
Right.
catalyst performance.
Yeah. So usually you have heterogeneous catalysts that are extremely expensive and they will be very subject to poisoning. And in that case, that chemical composition is critical, right? Anyway, just a loose question. What is the ideal biomass that you want to see to go with either platform, biochemical or thermochemical? And I guess that's important.
That point that we're talking about is consumption.
Uh-huh.
Hydrate function,
Energy, right. For cogeneration, yeah. Yeah, that's a good point. And obviously, not only lignin content, but reactivity. And one of you mentioned that point, right? Reactivity of lignin.
Another thing that we might have to consider is diversity, and there shouldn't be just one species, one source of material. We don't have to. We don't want to be in the situation when we find that somebody brought a beetle into the
Right.
U.S. and all of our materials are destroyed, and we need to use them right away. And that biodiversity and ecology also needs to be accounted for when
Right.
we're talking about.
And that's critical. That's a very important point. I agree. So,
I think that
Good.
also, maybe the social aspect also comes into play, maybe not as much, but I think that, like as an example, like in Chile, saturated the market with the land usage with eucalyptus and stuff, and it's an invasive species. And that's something that should be addressed, I think, as equal. I think, and I might be wrong here, maybe I'm being presumptuous, but I think that generally people wouldn't want their forests to be, the indigenous species to be removed
Right.
from the area. I mean, we're talking like massive amounts of land that's going to be devoted to,
Energy.
yeah, woody biomass. And,
Yeah.
and what that means is if we're putting like installing eucalyptus forests here, just massive amounts, or something, just as an example, eucalyptus, or just all pine stuff, I mean, I think that goes along with what you're saying about the
Yeah.
But I think also maybe, in my opinion, I think it's a really good idea to look into applications of indigenous species.
Great. Great input.
Particularly hardwoods, I think.
Yes. Yes. Dr. Park.
When it comes to diversity and then variations in species, I didn't present today, but we did some study using a molecular biomass map. We collect 150 root and 150 initially we thought that maybe the variation in factors speech left.
Mm-hmm.
Actually, it turns out the variation is actually larger than speech.
And that's eucalyptus from different plantations or locations?
So we collect 150 through different regions, different species, different age, and different habits, speech left about all this time. So we many comparisons and varieties, and think most of the overall time is very small, tiny, but
Mm-hmm.
also speech left is larger and eucalyptus is much larger. So we found a person who operates a mill, and I probably confirm about the variation.
Right.
Because if I use eucalyptus A and if I use eucalyptus B, then I probably need to see comparison.
Right. And this is for the thermochemical platform. And the same goes to the biochemical, maybe even more critical in that case, probably. So, very important consideration. Great input. Okay, since I want to cover more ground, I better move along and maybe put another thought. And this is about the pretreatment technologies. I didn't hear too much about it, but from what I understand, pretreatment is critical in the viability of the process. I don't think we didn't have too much of consideration to pretreatment technologies. Trevor mentioned dilute acid hydrolysis as the NREL way, at least system, that was used as a model to do this economic analysis. But there are other pretreatments that seem to be more effective as far as the economic viability. And that would include autohydrolysis and others. So we have a steam explosion. I'm talking here about mainly biochemical platforms. So FACS, steam explosion, dilute acid, right? And so on and so on and so on. So any considerations from the group about first, what is the role of pretreatment in this economical picture? And second, what are the indicators as far as the best pretreatment technologies for woody biomass to be converted to biofuels? Thoughts?
I guess unless we have a specific target biomass, it is hard to generalize. I think it depends on what biomass is coming. We have a full code of parking and extract and idea of which is
Very good.
And then pre-treatment, acidic crop, or your cellulose, or From our experience, substrates that are
Very important.
larger inventory rule,
Right.
so yeah, ultimately the goal is to try and preserve as much yield as also, yeah.
The hydrolyzed. And I have seen that, or we have seen that in the literature, right? I mean, lignin effects, inhibitory effects are really critical, and understanding the reason for those inhibitory effects is critical, and maybe it's something that still deserves more work.
Maybe even modification. I think also, modifications of the current pre-treatment we have. Say that these are pre-treatment methods that we already use.
Right.
Are what's the only methods. Maybe we'll I myself have been, looking into pursuing the avenue of doing fungal pre-treatment, lignocellulose. That has shown some promise, but there's still a lot of. Obviously, nobody really mentioned that in terms of pre-treatment methods. Maybe there's a good reason for that. I don't know. I'm hoping to be able to establish, if this is a viable alternative, and not necessarily alternative, but addition to, maybe like a craft open process or some sort of thermal.
Right.
So maybe, but that's just one possible avenue to pursue. Maybe there are other methods that are established.
Is anyone here in the room aware of pretreatment methods based on, for example, bio pretreatment using fungi that is maybe reported for biopulping or pulping, but in this case for biofuel production? Anyone aware of any report of that in that direction? That's one of the interests by Ben that he wants to explore. It's an interesting proposition. I think that deserves a lot of attention, and I think you have mentioned that before, but I want to reiterate. Pretreatment is critical. Okay. Yes.
Understanding the value of synergy.
Yes.
Instead of just saying like unicorn by itself.
Right.
We have papers out that show that there's synergy that
Combined together.
yeah, so treatment on chip file
Right.
before going into
It actually, yeah.
Right.
A lot of literature that I've been reading refers to as biocrafting, and that's exactly what you're saying.
Right.
In terms of if you subsequently use like a craft process.
Right. And in that case, it's to preserve cellulose that is actually beneficial for biofuel production as well.
It's a much milder, much milder conditions, a lot less chemicals that you have.
Right. So it's like conditioning the biomass. Okay, let's continue a little bit with enzymatic hydrolysis, then we will cover other grounds. I have there underlined a few issues, and that was the nature of my question in the previous talk. Cost of cellulase enzymes is a significant barrier. That's what I wanted to hear, and I guess that was the case. And here I have a number, but maybe this is outdated. It was being reported $0.5 to $0.6 per gallon of ethanol produced is maybe a cost that we can think about enzymes, at least in the past. But for this to make more economical sense, we're talking about $0.1 enzyme cost per gallon. That's a big target. So there's a big reduction here. And I wonder how that big reduction is going to be achieved. What do we need to do or to make this to happen, this enzyme cost reduction? There are many venues and many companies, I think, are big players in this area, but this is an important component. Comments?
Are those enzymes being able to recycling, reuse, so.
Enzyme recycling, that's a big issue, and I think there is interest research-wise about enzyme recyclability, enzyme mobilization, but all this is at the research level. I haven't seen anything actually that can be scaled up as far as enzyme recycling. But I think that's a key component that I think deserves attention.
How long it can actually, how many times you can use it.
Right. So, and for that you require separation schemes and unit operations that maybe are not that obvious at present time. No more thoughts? Okay, thermochemical processes, and this is Dr. Parks. He defined very well what gasification and pyrolysis is. The ultimate goal at the end is produce syngas, and from that liquid fuels, ethanol, diesel, methane, or butanol. Main issue here is that recovery rates are not that high, and there is still a major need to develop cost-effective thermochemical processes, and this has been so far a difficult task. In addition to that, I would like to underline the available coal or natural gas. The last one, natural gas in the US, very important, very abundant. And I see these two as an important competitor to this platform. And maybe I want to hear your comments about that. And then the cost of gasification. Here I have some numbers. In 2007 dollars, it was estimated for that conversion to the cost of that gasification conversion, $1.2 per gallon. And there is a goal set for this year, or was set for this year, much less, 0.82 cents per gallon. Very challenging, and I think these are not met yet. So there is an issue here, and I think this deserves a little bit of discussion. Comments? Coal, natural gas? What is going on? Could it be a threat for the future of thermochemical processes? I don't know, but I guess that's important for us to think. Dr. Park, comments?
Well, I mean, that's the case that many gasification startup companies or researchers, especially the natural gas,
It's coming big, right, in the US? Yeah. So we need to keep that in mind. Yes?
Analytic upgrading of sugar is very common. So from a financial perspective, advantageous, but life cycle around the process like that. So it starts to complicate.
Right. But it's very likely that that's going to come, right?
Yeah, I think that I don't see it as a bad thing necessarily.
Nice thought. Another point that I learned, and that was actually yesterday when we were driving over, we were driving Dr. Park and Trevor. He mentioned the blend wall. I didn't know what blend wall was, but I searched, I did my homework, and now I learned. And this is this requirement in gasoline in the US that is sold today to have at least 10% ethanol, E10. And for the students that heard Trevor mentioning the blend wall, this is what it is. In the gasoline that you buy, there is about 10% ethanol. Even though this is not actually met yet, you were talking yesterday about 9 point something percent, right? It's very close to be met. And that implies that in the US, 14 billion gallons of ethanol is being used, or is supposed to be used, to meet this E10 blend wall requirement, right? It's not yet met, but it's very close. Here what I found is about 12 billion gallons per year that is being used, and this is mainly from corn ethanol, right? Mainly corn ethanol. So the point is that I found interesting the fact that is underlined here is that once this blend wall is reached, that is about to be reached, the market will have problems absorbing any further production increases, and that will maybe push back this incentive that we want to see in the production of cellulosic bioethanol. Thoughts?
Someone was mentioning that they're discussing that blend wall is 15%, 20%.
That was Dr. Kelly.
That was Dr. Kelly.
An increase in the blend wall. Okay. The other option is, well, do like in Brazil or in other countries, talk about E85, for example, right? The problem in the US is, sorry?
The regulation has been changed.
Right.
Already last year, it's okay to have a higher.
Higher.
Protection. They don't use higher than 10%.
Right. Okay.
But there is a rule already. So there is also application as
20%.
At what point does it start affecting the inputs? That would be the ultimate barrier.
And this is something that needs adjustment, at least in the US. If you go to Brazil, there is, plenty of examples how the industry, the car industry has adjusted to those standards very nicely. But we are in a way lagging behind those changes. And when we come to use of E85 or greater use of E85, that is already in place but very limited, then we have to think on a full change of infrastructure and increasing the size of the flex fuel fleet. And there are many challenges here that will be coming in slowly but are not yet at present time. So this maybe is a change that is required, but it will take a little bit of time. Right.
Do you change the type of technology in the vehicle?
Right.
Or are you trying to change your fuel of the vehicle?
And when you have that type of situation, what is that will solve the puzzle? I guess policy intervention. You dictate you give a mandate, and then, we have to adjust to it, right? Okay, everybody happy? Blend wall. Then economy efficiency. This is related to total cost of producing cellulosic ethanol. And I was trying to catch up with Trevor's numbers, but he was reporting this in cents per liter. I was not able to do the conversion right away. But the numbers I have here, and you can correct me based on what you know, is that the estimates are for this to be viable, to be $2.4 per gallon and at present time. And this is more than twice the cost of corn ethanol. So woody-based or cellulosic-based ethanol is twice that of the present time corn ethanol. I don't know what Trevor's number was, but in terms of dollars per gallon. Right. So still, it's a big gap between corn and cellulosic ethanol, right? That remains the same.
Oh, yeah, it's much cheaper.
Right. Yeah. So that gap is a barrier. That's a challenge. There is a major impediment, and that has to do with the technology, right? The state of cellulosic conversion technology is not really there. There needs to be improvement in that conversion technology. So that I would think is critical, and these ideas of pre-treatment, enzymatic conversion is going to play an important role. Economy efficiency. A lot of unknowns. Okay. Oh, yeah.
Yeah, we're walking up
Right. And that's what we're seeing, at least from the discussion you provided. Okay. One thing that I want to maybe underline here in this slide is the co-products. Corn-based ethanol co-products can be used for animal feeds, and that's maybe the reason why I was asking about protein. In corn, one of the components that you saw in the composition bars is the protein content that is very limited in wood or non-existent. In the case of corn, it's very important, and that can be used for animal feed. But in the case of cellulosic ethanol, we don't have such residual, but we have actually a lot of lignin. So what to do with lignin? And you already are aware of many efforts in our department and outside about new utilization of lignin beyond power generation. That is important. I think that will fix or balance the economic and energy cycle. Nevertheless, that's still that remains still as an important component if we can use that lignin for higher value materials. So I guess my message is we need to keep that in mind. Environmental issues, I think Jesse touched upon this issue a little bit, but one thing that I understand is important is soil erosion, runoff, invasive species that Ben mentioned, and disruption of wildlife habitat. So for us to think, when cellulosic ethanol and energy crops are developed, these issues are very important, and I don't know if this has been factored in this simulation and analysis, but obviously these are important. One thing that I like in some literature that I searched very quickly is this Stommel diagrams. I don't know if you have seen this. It's about the environmental effects related to gasoline production or ethanol production. And I like here the fact that they are taking into account the time or temporal scale. We maybe didn't discuss that too much. And this is compared to the spatial scale. So maybe this is another way to look at the environmental impact, and in a way I like to present, maybe because maybe can be useful for some of your work. What you see on the left is the case of gasoline. Temporal scale, so in environmental impact, as far as oil exploration, extraction, distribution, and production, can depend on those different processes. You see there the scale. Oil extraction has the largest environmental impact, both in the spatial scale, because it can impact the globe. You can see there here. This is a logarithmic scale. And also in the temporal scale, how long those impacts can last. And here we have the larger this zone or these regions, the largest the environmental impact, both temporal and spatial. When we look at ethanol production impact, again, if we think this is a logarithmic scale, this is much less than the one that is relative to gasoline production. And if you look at the different components or equivalent components, biomass feedstock, biomass feedstock, harvest and collection, distribution of biomass and biofuel production, then those regions change quite a bit. So I just want to bring the point that this type of analysis seems to be very nice for any simulation work. Going beyond quantification in terms of cost, here in terms of time and spatial scale. And if you look at the spatial scale in the case of ethanol production, it's much more limited than globe. Usually here we have operations that are smaller in size, and therefore that environmental impact is much limited. Just a comment. And then I think this is about the last, or the one previous to the last, is the time frame for cellulosic biofuel production. The pace of plant construction falls short of the DOE initial plans or goals. It was thought in the past that by 2012, cellulosic ethanol was going to be a more mature technology. Is that the case today? I don't think it's the case, obviously. And we need to think about why is that. And that has to do with investment and interest from private companies as well as federal agencies, right? But that's the reality. Okay, so I just wanted to sort of give a closure as far as the points that I thought could be important, that maybe we miss a little bit and remain for us to continue thinking about. So with that, I think I end, unless you have comments or any other thing to add.
I just have a comment that there is a lot of, this is a great summary. This is a great overview of, all the steps that we discuss in this seminar. And the good thing is you highlight a bunch of realities, and those realities are challenges to us. I mean, we are in education research. We have to look at it, all of these points, as how we can change, improve, modify, face those challenges. But the other thing is, they are challenges that are already out of our control in terms of policies, for instance, incentives. So are we going to deal with incentive? Are we going to change that policy, or are they going to change that 10% into 15 or 20? Because if they're going to change from 10% to 25%, well, I do see a big window of opportunity. If they're going to change it from 10 to 12, well, my opportunities of investing in a large investment in a company, they're just going to make ethanol probably makes no too much sense, because the corn ethanol are going to catch up with that 2% pretty fast. I'm not going to be able to compete. Or tomorrow we might lose the government incentive to corn ethanol, and it's going to be too expensive, so it's going to be looking into different options. So this is just helping us to see the whole, the comprehensive analysis of where we are and all of those details and the challenges.
Right. So in my view, working more on the material side, for me, using wood to produce new materials and high value products is very critical and very important. And what I have seen is that after the hype of bioethanol and having a reality check as far as the cost scheme, where things doesn't seem to be as easy, I think one has to rethink about turning this a little bit around. And I can say that from what I hear, people are not only talking about bioethanol, but the sugar platform, and looking into solvents and precursor chemicals for polymers and other bio-based materials, right? So I think that type of integration will be critical, and that factors in the concept of biorefineries, an integrated processing unit where all these issues are relevant. Bioenergy, but also solvents, energy, and polymers and monomers, right, for the chemical industry. That will be critical. Now, in our department, there is a built-in expertise in this area, and I always wonder, what are we going to do with this expertise? How, if things don't work the best way we want, what are we going to do with this expertise? And I guess there are plenty of opportunities, because I see at Trevor doing a lot of work in many different directions, not only bioenergy, but other items. And the same goes for the thermochemical platform, biochemical platform, and the research that is going on.
Well, I can talk from my perspective, personal perspective, that basically I've been working on supply chain, and right now I've been applying all of this concept to the pellet industry. So if tomorrow the pellet industry just disappear or is not, a research topic anymore, I keep having all of that supply chain that can be applied to a different industry. And actually that supply chain came from the wood industry. So coming, understanding, primary, secondary, right. What we do in the drying and all the steps in the process is when I got my, understanding of the supply chain or interest in the supply chain, that right now it's pellets. So it's not like I am a pellet expert guy that just know pellets. It's
Yeah.
supply chain. So a lot of us in the department are just kind of, having that view.
Right.
And right now,
Uh-huh.
all of that knowledge is applied to cellulosic ethanol, but tomorrow it can be
Right.
to something else.
The good news, on the other hand, is if you see the private investment, I guess Steve presented that yesterday. There are many different units that are coming up, right? Pilot, semi-pilot in the US, and I hope that that will change the landscape a little bit, right? Because the factor that we had thought, there are many issues there. And important thing here is to think about private investment as being more long-range perspective, 10 years range, as the time frame that you use in your simulations, as opposed to shorter-term financial terms or that is subject to volatility, right? So I think this is very promising. Do you know how many installations are coming up in the U.S.? Any in the group has an idea? Yeah.
Demonstration.
Yes. Demonstration, commercial demonstrations, pilot, semi-pilot.
Demonstration of pilot.
Either.
There are many pilots.
Right.
Demonstration is much harder.
Right. And this is ongoing as we speak, right? I mean, this is in the coming years. So I think we have to wait and see what is going to turn out from those investments. But that can be a game changer.
I want to say that at least 3 of them are.
In North Carolina, there are several, right?
Oh, I don't know about it in North Carolina. I'm just trying to recite something that Dr. Kelly said, if I can find it. He was saying something about there are 3 full-scale lignocellulosic biorefineries for making ethanol in that have just recently either
Announce.
or they're either up and running or else
Okay.
they will be soon. I think it's in Iowa. One of them is Iowa, Mississippi. Can't remember.
Yeah.
Kansas.
Kansas. But it would be really. I think those things. That's happening is going to be really interesting to
Right.
watch them as a model.
Right. So this is very neat because where we are now, we're witnessing all this happening in front of our eyes, seeing what is going to happen. So I think this is a very nice opportunity for us to make a contribution in any way we can. So that will be a message for the students and the researchers in this area.